Okay, so the first thing that we are going to do is we're going to pretend that we've got $10 to be able to place bets on several different kinds of activities. And we'll say that that $10 starts over every single time. So you've got $10 for this activity, $10 for this one, $10 for this one, so on and so forth. Okay, so based off of the idea that you've got $10 and based off of these specific outcomes that we're looking at or events that we're looking at, we want to know what is a logical amount of money that you should bet per event. So when I say logical, I want you to think about what we're looking for, the odds that that event is going to happen. So then what would be the appropriate amount to bet? If you sit here and say, oh, I'm going to bet $10 on everything, or I'm going to bet $0 on everything, that's not a logical bet. Logical means you look at the experiment that's happening and you make an educated, sound bet based off of that. Okay, so we'll do the first one together. We're going to flip a coin and we're expecting it to land on tails. So out of $10, how much money would be a logical bet to make? $5, right? Because we know the idea of landing on tails is going to happen 1 out of 2 times. Okay, so if we take that 1 over 2, that outcome or that activity happening, and we multiply it by the $10, that's going to equal our 5. So $5 for the bet. Now you can have, for some of these, you're going to have decimal amounts. It's okay for you to have decimal amounts because money is in decimal form as well. You can only go to the penny spot though. So what I want you guys to do is with your table, you're going to look at each of these events that we're talking about, and you're going to identify the logical amount of money that you should place the bet on. Now keep in mind when we're talking about a die, it's got how many sides? 6 sides, okay? So you're wanting to land on a 5 or a 6 on the die. So here's my little die. When we're talking about selecting a male student, you're going to have to count how many students in here are male, and then count how many students in here, not me, students in here are female, and then come up with your idea from that. When we're talking about the spinner, everybody take a look up here. The spinner that I'm focusing on is a 5-section spinner. It's a 5-section spinner, 1 through 5. When we're talking about picking a highlighter out of a bag, I'm talking about picking a pink highlighter out of these 6 highlighters. If I were to randomly pick them out of those 6 highlighters, then what would be the possibility? And when we're talking about pulling hearts out of a deck of cards, so we've got our deck of cards here. There are 13 hearts out of 52 cards in the deck.
Wait, really?
Yeah. So we're gonna practice and play. Okay. All right. Go ahead and do that. So for problem number 2, we're gonna roll a die and we're gonna land on a 5 or a 6. So how many numbers are on the die again? 6. How many ways can we land on a 5 or a 6? 2, right? You can land on a 5. There's one of them. You can land on a 6. There's another one. So that's 2 different ways that you can land on it. So we have 2 ways that we can get a 5 or a 6 out of the 6 numbers on the die. So when we multiply that by 10, that's going to come out to $3.33. Okay, so $3.33 is our what?
The line.
Well, money doesn't have a line.
No, I would like to indicate that it keeps on going on and on.
Understood, but we're talking about money. Money has a stopping point, so you round it to the penny spot. All right, for problem number 2, randomly selecting a male student. How many boys are in the class?
14.
Out of how many?
10.
23. So 13 times 23, or 13 over 23, we're going to multiply that by 10. You would get $5.65. 65 cents. Well, you got it wrong. All right, $5.65, because it would keep going on and on and on, but you have to make sure that you estimate it correctly. All right, for problem number 4, the spinner. So how many numbers were on my spinner? 5. How many of them were even? 2 of them, right? The 2 or the 4. The 2 or the 4 is considered to be even. So we have a 2 possibilities out of 5 total numbers. So we're going to multiply that by 10, and you would be able to bet $4. $4 would be a safe bet that if the event happened, great, you get $4. If it didn't, then fine, you only lost $4. All right, for problem number 5, randomly selecting a pink highlighter out of my 6 highlighters. So that means we have one way of that occurring out of the 6 highlighters that are possible. So when we multiply that by 10, best estimate is going to be $1.67. If you round it correctly, I know a lot of you probably put $1.66 because you're like, oh, the 6 repeats, but you want to estimate it. You round it so that penny rounds up to the 67. All right. And then pulling a heart from a deck of cards. That's going to be 13 hearts. There's 13 hearts in the cards out of 52 total cards. Or you could simplify it to 1/4 because there are 4 suits, and all 4 suits have the same amount of cards. So there's one suit that's a heart out of the other suits, okay? So you could have done either one of those and then multiplied that by the 10. You'd get $2.50 is the logical bet that you could create, okay? All right, any questions?
No.
Fantastic. So with our probability unit, we do have a lot of terminology, a lot of vocabulary that you need to make sure that you keep in mind. We'll be using those because I'm not going to be breaking it down and going, oh, we're going to do this number of times. You're going to hear words like experiments, trials, outcomes, and events. So you want to make sure you have a good understanding of what those stand for. So when we talk about an experiment, with an experiment, it's an activity involving chance. So for example, flipping a coin. That's an activity that involves chance. When you spin a spinner, those are activities of chance. Rolling a die is an activity of chance. Okay? If I were to put all of your names into a hat and then I pull a name out, that's an activity of chance. So those are called experiments. When we talk about trials, trial is a repetition or observation of an experiment. Basically, that means the number of times that you are going to perform your experiment. So if I'm going to flip a coin 100 times, then that means it's 100 trials. So it's the number of times you perform an experiment. Number of times that you're going to perform your experiment. Okay? Then we have our outcome. Our outcome is the result of the experiment. So when I flipped the coin, what did it land on? When I rolled the die, what did it land on? When I spin the spinner, what did it land on? So basically, it's the idea of what did you get? Your outcome is what you got when you performed your actual experiment. And then we have our event. So our event is a set of one or more outcomes that you're wanting to have happen. So here, my event for problem number 1 was landing on tails. It's what I wanted to have happen, or what we would call a desired outcome. So it's the outcome that you are measuring, what you're looking for, not what you actually had happen. So there's a difference between what you want and what you get. Okay? Now, when we are talking about probability, our probability does have a number line that it references, where you have 5 different vocab terms that we use to be able to characterize our probabilities. So at the very far end, another thing I want to make sure you understand, probability is written in 3 different formats. You can write it as a fraction, always making sure the fraction's in simplest form. You could write it as a decimal, or you could write it as a percentage. When we write it as a fraction or as a decimal, the range goes from 0 being the smallest possibility to 1 whole being the largest possibility. You do not have any such thing as probability being greater than 1. 1 is the largest probability is able to be. If you write it as a percentage, 1 whole would convert to 100%. Okay, so if it happens exactly 1 time or 1 whole time, or the probability is always going to happen, it's 100%. Okay, so percentages are out of 100, fractions and decimals are out of 1 whole. Okay, now at the very far end of the spectrum where we see 0 or 0%, we call those probabilities impossible events. Okay, no matter what, they will never be able to happen. Okay, the probability of me being able to walk out of this classroom and dive into the ocean right now is impossible because there is not an ocean right here outside of my classroom. I would have to drive to a beach and then I'd be able to frolic all I want. Okay, today is Monday. The probability that tomorrow is going to be Friday is impossible because Friday does not happen right after Monday. Okay, it's Monday, Tuesday. So these are things that we deem impossible to happen. Having this set of highlighters right here, the probability that I'm going to choose a black highlighter is impossible because there is not a black highlighter involved. Okay, so these are things that will not be able to occur. They have 0 chance of happening. Right in the center, right in the center at 1/2 or 0.5 or 50%, we call those equally likely outcomes, meaning that half of the time it can happen and half of the time it does not. So it's also known as the as likely as not. It's just the same chance of happening as it is to not happen. So I'm going to write both of those terms down. As likely as not, or equally likely. Those are the terms that we deem 50%. So a coin is an equally likely experiment. Half the time it can land on heads, half the time it can land on tails. Okay? If I have a die, landing on an even number on this die is an equally likely event, because half of the numbers are even and half the numbers are odd. So there are equally likely situations. Okay, all the way at the very far end to the right of the spectrum where we've got 1 whole or 100%, those are the terms that we deem certain. Not possible, certain. They are guaranteed to happen. So today being Monday, it is certain that tomorrow is going to be Tuesday. Okay, so those are events that will always happen. They are 100% going to happen. Then you've got the things that are in between. Now these are not, notice that these are all specific numbers. It has to be exactly 0 for it to be impossible. It has to be exactly 1/2 or 50% for it to be called equally likely. It has to be exactly 1 whole or 100% in order for it to be called certain. The stuff in between, those are ranges of values. So anything in between 0 and 1/2 is called unlikely. So I'm going to highlight those in my orange. Now, even though these have a huge range of what they are called for unlikely, they do have levels of unlikeliness. Okay, starting to the left side, we call those very unlikely, all the way up towards the right where we would call it slightly unlikely. Because as it approaches its different ends, when it's approaching an equally likely section, the unlikeliness of it gets less and less and less. Okay, as it's approaching the impossible scenario, the unlikelihood of it happening is greater and greater and greater. Okay, so they do have ranges of unlikeliness. Then you've got between 50% and 100%. We call those likely. And again, they also have a range of likeliness. the closer it is to that 50%, the slightly likely it is. The closer it is to certain, the very likely it is. So it does have a range of likeliness there as well. And then when we are talking about probability, like I said, can be written, most of the time it's going to be written as a fraction. You will see it written as decimals and percentages every so often, but for most part, we tend to focus on it in its simplified fraction form. And the fraction is created by identifying the number of ways to get the event, that desired outcome that you're looking for. How many ways can I, call on a male student? Well, there's 13 males in here, so there's 13 ways that I can call a male student. And then on the bottom, it's the total possible outcomes. So yes, I can call on 13 different males out of 23 different students in the class. Okay, so the number of ways you can get your desired event over the total possible outcomes that are available to you. So for here, what we're going to be doing for the following problems is we're going to determine whether the following events are considered to be impossible, unlikely, equally likely, likely, or certain. So you're going to look at each one of these proposed or desired events that we're wanting, and you are going to find what the probability would be based off of the fact that we just identified that probability can be found as the number of ways to get that event over the total possible outcomes. So identify what that would be as a fraction, convert it to percent if you need to, and then based off of those responses, would that represent an impossible scenario, an unlikely scenario, an equally likely scenario, likely, or certain? Go ahead and take 2 minutes to do that. So for problem number 1, it says picking a month with 28 days in it. How many months have 28 days? 12. There are 12 months that have 28 days in them. You have a January 28th, you have a February 28th, you have a March 28th. Did it say only 28? It says pick a month with 28 days. Well, you read an extra word in there. Okay? So there are 12 months that have 28 days within them out of the total number of months that we have, which was 12. Okay, so when you simplify this, 12 over 12 can simplify to 1 whole, or as a percentage, that can be 100%. So what outcome do we call that? Certain. That is a certain possibility. Okay. Problem number 2. You are rolling a number that is greater than or equal to 3. Greater than or equal to 3. How many numbers are greater than or equal to 3 on a number cube?
97.
How many numbers are greater than or equal to 3 on a number cube? 4. There are 4 numbers. There are. Shh. Is 1 greater than or equal to 3? No. Is 2 greater than or equal to 3? No. Is 3 greater than or equal to 3? Yes. So the number 3, what about 4? Yes. 5 and 6. Okay? So there are 4 total numbers. 4 total numbers. And then the die has the numbers 1, 2, 3, 4, 5, and 6 on there. Again, so you have 4 out of 6. 4 out of 6 can simplify to 2/3. Or we can look at it as like about 67%. That is considered to be a likely scenario. You have 4 total numbers on the die that satisfy the condition of being greater than or equal to 3. So you have 4 out of 6. Okay, problem number 3, flipping a coin and landing on tails. So the outcome that we are wanting is just to land on tails. How many ways can we land on tails? 1. There's only one way to land on the value of tails. How many possible outcomes are there on a coin? 2. So you have 1 out of 2. 1 out of 2 can simplify to just 1/2 or 50%, which is called what?
Equally certain.
Not equally certain. Stop making up stuff.
Equally likely.
Equally likely or as likely as not. Those are all considered to be possible ways to say it. Io, sit in the chair. Do not raise the chair over your head. Don't put the chair onto your back. Sit in the chair. Problem number 4. You're spinning the spinner, same spinner that we had before. Spinning this spinner, and we want to land on the 15. Okay, so we are looking to land on the number 15 out of a list of numbers that are 1, 2, 3, 4, 5. So how many of these numbers are a 15? 0. There are 0 numbers on here that are the 15 out of the 5 numbers that we have on that die, or on that spinner. So that's considered to be 0 or 0%, which is impossible. Please stop talking. Okay, so we have 0 or 0%, impossible outcome. Okay, now, next terminology that we have, another vocab word that we need to have an understanding of is the term complement. So when we talk about a complement, we're talking about the probability that the event will not occur. So they're giving us a probability that it will occur. We want the probability that it will not occur. So taking a look at problem 1, get a bag of marbles, 6 red, 6 blue, 3 green, and 1 yellow. They've already calculated the probability that red is going to occur. Red will occur 3 out of 8 times. Even though we have more than 8 marbles, and we have more than 3 reds, it would be 6 over 16, because if you add all these marbles together, you would get 16. 6 over 16 would simplify to 3/8. So 3 out of 8 is considered to be the probability of red. I want the probability that it is not going to be red. So what you do in this situation is you take what's the largest possible probability you could ever have. Again, what did I say was the largest? 100%, or as a fraction, that is what? 1 whole, right? You take your largest possibility, 1 whole, and you subtract the probability that you know. We know that the probability of red is 3 out of 8. I want the probability that it's not red. So it's either going to be red or it's not going to be red, right? Blue is not red. Green is not red. Yellow is not red. Okay, so let's pretend that they did not give us a listing of all these, and the only thing they told you was that the probability that red would occur is 3 out of 8. Then what you would do is you would subtract your probability away from 1 whole, and what's remaining is the probability that it's not going to be that event. Now, we can change 1 whole into a fraction. What fraction should I change 1 whole into in order to make the subtraction easier? What do you think, Io?
8/8.
8/8. Okay, we want to change it into 8/8. How did he come up with 8 over 8? Why wasn't it like 5 over 5 or 3 over 3 or 12 over 12? He chose 8 over 8 because the denominator was 8. Our denominator already was an 8, so we're going to choose the same denominator. And remember, if it's 1 whole, your denominator and your numerator are going to be identical. So all we've done is just take this information and changed it. We just changed 1 whole into 8 over 8, and then we can go ahead and subtract. So 8 over 8 minus 3 over 8 is going to give us 5 over 8. And that's the probability that it is not red. Probability of not being red is 5 over 8. Go ahead and do the same thing for problems 2 and 3. Find the complement, the probability that that event will not occur. So for problem number 2, the probability of rolling a 5 or a 6 is 1/3. We want the probability of not rolling a 5 out of 6. What would that probability be? 2/3. Okay, so we would get 2/3 for that probability. So again, all you would have to do is take 1/2, or 3 out of 3, and subtract the probability of 1/3, and that would come out to the 2/3. Okay, what about for problem 3? Picking a queen out of a deck of cards is 1 out of 13. What's the probability of not picking a queen? That would be what? 12/13. Okay, again, so picking a 1/2, which would be 13 out of 13, we would subtract the probability that we do have, which was 1 out of 13, and that's going to leave you with a probability of 12 out of 13. Okay, so you should have gotten 2/3 and 12 out of 13. Go ahead and flip it to the last page. Okay, so again, taking an understanding of our vocabulary that we have come across, if Eric's teacher almost always gives a quiz the day after a lesson that students didn't ask many questions, then should Eric expect a quiz on Monday if no one asked questions during Friday's lesson? Let me read it again. Mason, head up. Eric's teacher almost always gives a quiz the day after a lesson that students didn't ask many questions. Should he expect a quiz on Monday if no one asked questions during Friday's lesson? What do you guys think? Yes or no?
No.
Okay. Why would you say no?
Noise.
But Monday is the day after, is the next school day, right? Yeah, so we're thinking school days. Obviously, it's not going to be, he's not going to give a quiz on a Saturday because he's not there. Okay, so don't think of it as in terms of weekday, like actual days of the week, but think of it in terms of school days. So yes, why would you say yes? What up here can support you or provide evidence to why you think he should expect a quiz, Tyler? It says almost always, right? The term almost always is referencing that this is a likely event. This is a very likely event to occur, okay? Almost always represents a likely situation. And so since the students did not ask questions, then they are confirming that likely event. Now, is it guaranteed to happen? No. But it's got a strong chance of happening. So we would say yes, he should expect a quiz that day. What about for problem number 2? Todd rarely watches TV for longer than 30 minutes in the afternoon. If he started watching TV at 4 p.m., how likely is it that he is still watching by 5 p.m.? Why do you say not likely? Carol? Because it says rarely, right? The term rarely is an unlikely situation. It's not impossible. It's not impossible to occur. He could potentially still be watching, but very rarely does he watch for more than 30 minutes. So at this point, by 5 p.m., it's been an hour. So the chances of him watching are probably small. Not impossible, because if in order for it to be impossible, instead of it saying rarely, what would be a word that would represent impossible? Huh? Never. If it said Todd never watches TV longer than 30 minutes, then we would know that that would be an impossible event. But this time it says rarely. That's an unlikely event. Okay? All right, and then down here, I want you guys to go ahead and fill in these problems. If you have a spinner that is labeled 1 through 7, so that means that you've got possible outcomes of 1, 2, 3, 4, 5, 6, and 7. Those are your possible outcomes. I want you to identify the probability of landing on a 5, the probability of landing on an even number, probability of landing on an odd number. Go ahead and fill those out real quick. All right, probability of landing on a 5. How many 5s are there? 1 out of how many numbers? 7. So if we do 1 over 7, that's approximately 14.3%. Okay? approximately 14.3%. Is that what's the likelihood of that? Is that impossible? Is it unlikely? Is it equally likely? Likely? It's unlikely, right? Is this an unlikely situation? What about an even number? How many even numbers? 3 out of 7. So 3 over 7. If we do 3 divided by 7, multiply it by 100, you get your percentage. So that's 42.9%. What's the likelihood there?
Unlikely.
Unlikely. Still unlikely. However, if we were to try to give a better range or better terminology to these, 14.3% would be very unlikely, whereas 42.9% would be slightly unlikely. Okay, so there's a difference in unlikeliness for those two. All right, odd numbers. How many odd numbers? 4 out of 7. So if we do 4 divided by 7, and then, to change it to a percent, you multiply by 100, we would get about 57.1%, and that is
Equally likely.
no, likely. Equally likely means it has to be exactly 50%. This is not exactly 50%. Okay? This is just likely. Slightly unlikely. Slightly likely. Okay? All right. Loaded in Google Classroom. You have your assignment. Go ahead and get started.